The next topic is upsampling. Upsampling is the process by which the samples of a discrete time signal is increased by a factor Let x of n be the input to the upsampler and L is the upsampling rate, then y of n can be represented as x of n by L. The device that performs the process of upsampling is known as an upsampler. Symbolically, an upsampler can be represented by an up arrow followed by L. And x of n is the input and y of n is equal to x of n by L is the output of the upsampler. Let us take an example. X of n is equal to 1 3 minus 1 2 is the input. If I want to upsample x of n by 2 by a factor, which means that this x of n is upsampled by a factor 2, so the output y of n is equal to x of n by 2, which is 1 0 3 0 minus 1 0 and 2. Here when we doing an upsampling by a factor of 2, we retain all the samples and inserting 1 zeros in between each samples. For an upsampling by 3, it is 1 0 0 3 0 0 minus 1 0 0 and 2, which represents that it will retain all the samples in the x of n, and also it inserts 2 zeros in between the adjacent samples. So in general, if I want to represent an upsampler by a factor of L, which means that it retains all the samples of x of n and inserts L minus 1 zeros between each adjacent samples. Let us go for the spectrum of the upsampler. Let x of n be the input and upsampling factor is L, and y of n is equal to x of n by L, which is the output. So this can be symbolically represented as an up arrow followed by L, and the input is x of n and y of n is the output. Taking the Z transform, y of Z is equal to summation n is equal to minus infinite to plus infinite y of n into Z raised to minus n. That's equal to summation n is equal to minus infinite to plus infinite x of n by L Z raised to minus n. Let n by l is equal to some u, and u is equal to sorry, n is equal to ul, as n takes the value minus infinite, u takes the value minus infinite, and n takes the value plus infinite, u takes the value plus infinite. So y of z can be written as summation sum u is equal to minus infinite to plus infinite x of u into z raised to minus ul. Yeah, y of z equal to summation u is equal to minus infinite to plus infinite x of u into z raised to u, x of u into z raised to ul, minus ul, minus ul. That's on rearranging u is equal to minus infinite to plus infinite x of u into z raised to l the whole raised to minus u. So this is equal to x of z raised to u. On applying z equal to e raised to j omega and y of z equal to x of e raised to j omega l. This equation is the frequency spectrum of the output signal of the interpolator. The term x of e raised to j omega l is the frequency compressed version of x of e raised to j omega by a factor of l. Since for a signal x of n and the spectrum will repeat at the intervals of 2 pi, here also the spectrum will repeat at the intervals of 2 pi, and also the spectrum will compress so these are the images of the original spectrum. Original spectrum. And since there are images, I want to reject these images. So after downsampler, I will apply a filter which is an anti-imaging filter whose cutoff frequency is pi by L, which means that there are L minus 1 images will be there in between the 0 and 2 pi. So, and this upsampler plus a filter is termed as interpolator. Thank you and all the best for your exams.